Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher, and very good evening to everyone. Let me inform the students that we are live. Okay, so everyone, how are you all? Everybody in the comment section. Am I visible? Am I audible to everyone? Everybody, I'll just text this in the Telegram channel, right? Okay. I know always and always ma'am needs to inform you, है ना? Okay. So very good evening, Nandu, Soumya, Balu, Nalini, Vishali. Okay, very good evening, guys. So let us start the session, right? Because every single minute is very important for you. So without wasting any time, let us start the session. Just let me know if I am completely visible and audible to you. Right? Okay? Yes? Okay, perfect. Okay, Ji. Now let us start the session. Firstly, we'll be doing some formulas. Firstly, we'll be revising the formulas of thermodynamics, right, in a very short manner. And this particular session is not going to be very long. This is going to be maybe 1.5 hours or maximum 2 hours. That's it. Okay, so are you all ready for that? Yes, everybody? Okay. So, firstly, let us start with the short notes, okay, that I have prepared for you. Now, firstly, I'll tell you all the terms on which the questions are asked. Firstly, we will talk about the terms. Then we will talk about different formulas from where the questions are asked. So first thing is talking about the intensive and extensive property. Intensive property is that which depends on the matter, right? Okay, intensive, wait a minute, it should be the opposite. Let me just correct it. Intensive is independent and extensive depends, okay? Intensive is independent and extensive is which depends. I for intensive, IN intensive and IN is independent. So intensive property are independent of the matter, but extensive property are dependent on the matter. If you talk about the examples of intensive properties, you have P, T, density, melting point, boiling point, EMF, refractive index and refractive index, viscosity, surface tension, and the specific and molar properties, right? Because in specific and molar properties, in specific we specify 1 kilogram, right? We have taken that 1 kilogram, so now it is not dependent. In molar property, we specify that we are talking about 1 mole. So that is the reason all the quantities which has specific heat capacity, molar heat capacity, they are independent, right? If you talk about simple heat capacity, right? Here you can write the example heat capacity, that is dependent on the matter. Extensive property means which will depend on the matter. So heat capacity, right, we will learn about heat capacity in detail, right? That is dependent on matter, but specific and molar heat capacity is independent of the matter, that is, it is intensive. Rest of the things are, if you talk about internal energy, you talk about Gibbs energy, you talk about enthalpy and entropy, right? That is HGUS. HGUS, enthalpy, Gibbs energy, internal energy and entropy, all they are extensive properties, right? Okay, that means they are dependent on the matter. Now, one more thing about this is mass is extensive and volume is also extensive. When you talk about two extensive property, the division of two extensive property is nothing but the intensive property. So if I talk about density is equals to mass by volume, this is extensive, that is why density is the intensive property. That is why here we have written density. Okay, that is why we have written density here, right? Okay, yes students. Now next thing is state function and path function. If you talk about state functions, path functions, this is the second definition. Talking about state function, that is dependent on the state. Like if you're going from A part to B part, right? A point to B point. A point to B point. Now it doesn't matter. You are following this path, you are following this path, you are following this path, you are following this path. It doesn't matter. It's just that what is your initial state and what is your final state. It is only dependent on that. Those are called state functions. Okay. Now, second is what is a path function. Okay. So path function is which is dependent on the path that you are taking. Whether you're going from this path, this path, this path, this path, that quantity will change, right, according to the path that you will follow. Now, if you talk about all the quantities that we are going to talk about, Gibbs energy, enthalpy, entropy, internal energy, basically UGHS, that is, or you can say HGUS, whatever you want to learn, right? These are extensive and these are also the state function. Direct question will be asked to you based on this simple fact. Okay, so that is why when we will learn about in delta U, we will just say U final minus U initial. Delta H is H final minus H initial. We don't only talk about the path. It doesn't matter what is the path. It is a reversible process, irreversible process, doesn't matter, right? Okay, so that is why delta H, delta U, delta S, it does not dependent. It is only dependent on the final and the initial position, right? Okay. Now, next is you have path function. So in path function, you have W and Q, that is your path function. Work done, and Q is the heat energy, right? Q is the heat. Q is the heat. And W is the work done, right? Now, we have 5 thermodynamic processes, right, which we will study in detail as well. The formulas, or also we will discuss about thermodynamics formulas of different processes. Right. So first process is isothermal, then isobaric, isochoric, adiabatic, cyclic. Isothermal, iso means same. Thermal means temperature is same. So in this case, temperature is same. Now, whenever, remember one thing, internal energy is a factor of temperature. If temperature is constant, internal energy is going to be constant. So that is why for isothermal process, we can write dt is equals to 0 and delta U is also equals to 0 because internal energy is a factor of temperature. Right. Second is isobaric. Now, bar is a unit of pressure. That is why here we are saying isobaric. That means pressure is going to be constant here. Isochoric is volume is going to be constant here. Next is adiabatic. In adiabatic process, for example, you are increasing the temperature. The temperature is changing, but in that particular compound, in that particular container, the heat energy is the same. That means whether the temperature is increasing or decreasing, the heat energy is constant here, right? In that case, what can happen? If we are heating something, it is continuously giving off that heat. For example, I am a person, you're giving me 5 books, right? I am not holding those 5 books. I am just giving it to someone else, right? So that is why I am continuously releasing or changing my heat, right? So heat in that container is going to be 0, right? So heat is same. System cannot exchange heat with the surrounding. The heat is going to be 0 in this case. There is no exchange of any heat energy, whether you increase or decrease the temperature. Next is cyclic process. Cyclic process is like a loop. Okay, it's like a loop. So in a loop, what exactly happens? This is A to B, then you have B to C, then you have C to D, then you have D to A. From where I have started, I will come to the same point in the end. I have started from A, I'll come to the A point. Now guys, very interesting thing about this one, that in the cyclic process, all the state functions are going to be 0, right? All the state functions are going to be 0. Whether you talk about delta H, delta S, delta G, delta U, all of them will have 0 value. Can you tell me the reason? Because it was dependent on the state, right? And now the state is changing. State is same only. If I started from A, I'll end on A only. That means initial and final position is same. That is the reason it is not dependent on path. That is why state functions are going to be 0. Okay, state functions are going to be 0 here. Now, next is first law of thermodynamics, right? Okay. A clear picture we have seen, right? Now let us talk about first law of thermodynamics. In physics, you must have seen a different equation, right? Because the work done, the sign convention of work done are different in that case. But now here I am telling you, in chemistry, see, answer will going to be same. If you apply physics formula, you should also apply the sign convention of physics, right? Okay. But in that case, what will happen? You will get confused in other formulas of chemistry. So for chemistry, just remember this formula, that internal energy change is equals to heat energy, that is Q, plus W, that is the work done, right? So if you talk about what is heat energy, the sign conventions here, right? Just remember one thing, that if I talk about heat energy, right, that is Q. So whenever you have to give something to someone, you will feel negative, right? So when it has to release the energy, the heat energy is going to be negative. That is why heat released is negative. And when you are going to gain something, someone is giving you money, you will feel happy, you will be positive. So heat absorbed is going to be positive, right? Okay. Now, ma'am, what about work done? In work done, how you will remember? There is compression and there is expansion. Two phenomena we have, right? Okay. So just remember it this way, right? That compression. For example, here what exactly term you need to remember, that is on the system and work done by the system. Tell me one thing. If ma'am has made notes for you, right? Ma'am has made all the handwritten notes for you, right? Everything I have collected from thermodynamics. Good question, previous year question I have already collected. In just next 1.5 hour, you just have to study. You are happy about this, na? Ma'am, you are saving our 4 to 5 hours. Ma'am, I'll be just writing these short notes. Maybe it will take me 2 to 3 hours to revise this. You are going to revise this in next 30 minutes. So, ma'am, you are helping me in that. So, work is done by the system, right? So, I am the one who is doing the work and you are not doing the work. So, I can't say you are doing the work. Work is done on you. So, whenever work is done on you, someone else is doing work for you, you will feel positive about it. So that is why whenever work is done on the system is just relaxing and chilling, right? So in that way, work is going to be positive here. But if system has to do the work, system will be like, Arey yaar, I have to make the notes, solve the questions, so much work to do, right? So system will feel negative about it, right? Okay, understood? Now, understand one thing. Work is done on the system. Whenever we are doing the work on the system, compression is happening, right? Okay. So, compression is happening. So, compression is also called as, one more question they can ask you, one very good question they can ask you is, compression is basically cooling. See, whenever molecules are getting closer to each other, that means cooling is happening. If temperature increased, molecules send away from each other, that means expansion is happening, right? Work is done by the system, expansion is happening. Molecules are going away from each other. So whenever molecules are going away from each other, in that case, can I say heating we are providing it heat, right? So that is why expansion, instead of expansion, they can also write heating, right? Instead of expansion, they can also write heating here. So you don't need to get confused here. They can give you different things here. They can say on the system, compression, cooling. This means the same thing. This means the same thing. Got it? Yes, everybody. Next is the formula of work done. Work done is equals to minus P delta V. Okay, this is the formula of work done. Now, one more question they can ask you, that this is the graph, this is the graph. Now, this is 1 and this is 2. This is 1, this is 2. Which is what graph? Now, always remember that isothermal and adiabatic both are having the same kind of graph, right? But adiabatic graph is steeper as compared to isothermal graph. Okay? Adiabatic graph is steeper as compared to isothermal graph. Now let's see the graphs of isothermal, isobaric, isochoric curves, right? So just remember one thing, that is PV is equals to nRT. Just remember this thing, that is PV is equals to nRT, right? So when they are saying isothermal, now N and R are always going to be constant. N is the number of moles, R is gas constant, that is universal constant, right? So they are always going to be constant. So can I say PV is directly proportional to T? This is ideal gas equation. Can I just write this thing here everywhere? Now they are saying that T is also constant. That means PV is basically constant because time, temperature is also constant, right? So PV is equals to constant means P is inversely proportional to V. Now, here we will draw all these graphs. So if you talk about pressure and volume, when X inversely proportional to Y graph is drawn like this, okay? When X and Y are inversely proportional, right? The graph that we draw is like this. So that is why graph is a curve, right? Next is V and T. Now volume, temperature is constant. Temperature is not changing, but volume is changing at every single point, right? So that is why it's a straight line graph parallel to volume, right? If you talk about this one, pressure is changing, right? But temperature is constant. So that is why it is a straight line graph parallel to pressure, right? So that was about the isothermal. Next is isobaric. Next is, guys, isobaric. Again, we know that PV is directly proportional to T, right? Now here pressure is constant. That means just eliminate pressure from here, right? So P is directly proportional to T. P is directly proportional to T. Let's draw the graphs now. Between P and V, we know that pressure is to constant. So that's why at every volume, pressure is going to remain the same only. That's why it's a straight line graph parallel to volume, right? Next is volume and temperature. Now, this is a graph of y is equals to mx plus c. Because the intercept is 0 here, this is a straight line graph, okay? Intercept is 0 here, that is why it is starting from the origin only, right? And from the origin, it is going straight line, okay? Not parallel to x or y axis, it's a straight line, but it is not parallel to anything. X or y axis, it will be parallel to only if either x axis or y axis is constant, right? Now, next is P and T. Again, isobaric, pressure is constant at every temperature. So, it is parallel to the temperature here. Next is isochoric. Now, guys, isochoric, just draw this thing. PV directly proportional to T, right? Isochoric means the volume is constant here. So, we'll take volume as constant. P is directly proportional to temperature, right? Now, if you draw a graph of P and T, that will be a straight line because it is y is equals to mx plus c kind of graph with intercept 0, right? Now, next is volume is constant at every temperature, right? Volume is constant at every pressure. So that is why these are going to be the graphs here. Students, tell me, is that clear to everybody? Isobaric, isochoric, and isothermal graphs, are all these clear to you or not? Because now we are going to do a very, very interesting question, right? That is of a cyclic graph and what they can ask you, right? This question can be asked directly to you. It's a very, very important question. They can ask you C, D, A, B, which a particular curve is representing what kind of thing. Is it representing cooling, expansion, compression, heating? These kind of things they can ask you. Okay, yes. Now this is a loop, okay? Starting from one point, you are coming back to that point, right? Now, as I told you, all state functions are going to be 0 in cyclic graph, right? Now, here from A to B, what is the name of the process? B to C, what is the name? C to D, what is the name? D to A, what is the name? Let's understand that. From A to B, beta, we know that exactly pressure is constant at every change in volume. Pressure is constant. That means, can I say this is isobaric graph? So that's why we have written here. You can just write here. You can just write here. A to B is basically isobaric. A to B is isobaric. B to C, what is constant? What is constant? Volume is constant. From B to C, volume is constant. So can I say it is isochoric? it is isochoric, right? C to D, again pressure is constant, so it is again isobaric, right? D to A, again volume is constant, so it is isochoric. That was a simple thing, right? That was a simple thing that they can ask you. Now let's move to the interesting part here. Interesting part is, firstly, from A to B, we know that volume is increasing, right? Now I'll tell you how to predict whether there will be heating, whether there will be cooling. Right, from the graph you have to tell whether it's heating or cooling curve, what kind of curve it is. Right. So from A to B, we know that volume is increasing. But now important thing is they should tell you that the arrow is going from this side to this side. That should be mentioned in the question only. Right. So this is going from this side. That means the volume is increasing here. Volume is increasing from A to B. Volume is increasing. So if volume is increasing, that means expansion is happening. And I told you that whenever expansion is there, molecules are moving away from each other, we can relate it to heating. That's why in the option, they will not give you expansion. In the option, they will give you heating. You'll say, how can we predict with this that heating is happening? Because volume is increasing, that's why heating is happening, right? Next is B to C. Now we know that volume is constant here, but pressure is decreasing. And pressure is inversely proportional to volume. Is it? Pressure is inversely proportional to volume. If pressure is decreasing, pressure, when you apply the pressure, compression happens. When pressure decreases, expansion happens. Right? Pressure decreases, expansion happens. That means again it is heating curve. Right? C to D. C to D, guys. Now what is happening here? Volume is decreasing. Volume is decreasing. Compression is happening. In compression, we relate it to cooling, right? Okay. D to A, first you tell me in D to A, pressure is decreasing or increasing, volume is increasing or decreasing, right? Okay. In D to A, pressure decreases, volume decreases, pressure increases, volume increases. Everybody let me know in the comment section what you can say about D to A. What you can say about D to A. D to A, volume is constant here. Volume is constant. Now tell me whether pressure is increasing or decreasing. Pressure, guys, it is increasing. From the graph, tell me, is it decreasing or increasing? What is happening here? I'm waiting for your answers in the comment section. Right? Okay. Very good. Okay. Yes. So here it will be very good. Pressure is increasing here. Pressure is increasing here. So guys, when the pressure is increasing, right, you're applying the pressure, right? You have a container, you're applying the pressure with the help of a piston, you're applying the pressure. Here molecules are getting closer to each other. That means cooling is happening here. That means we can say that here cooling is happening. So answer will be cooling, right? So got it about this curve, how they can ask you about heating and cooling effects here. That is clear to everybody. Very good. Pressure increases, volume decreases. Yes. Okay. Now, let's talk about reversible and irreversible processes, right? From where the questions are asked based on the work done. Especially in isothermal and adiabatic, they ask you the questions from work done, in which they will not directly give you whether this is irreversible or reversible. You have to take a hint. Hint I am going to tell you by explaining you. See, in numerical also you need to have conceptual knowledge, and this is the conceptual knowledge that you need to have to solve the questions of isothermal reversible, isothermal irreversible, adiabatic reversible and irreversible works, right? Okay, let's talk about this thing here. Okay, now irreversible, just think about a story. Which story you will remember it for longer run, right? Okay, yes. Now, if you talk about irreversible work done, right? Irreversible means I can't go back to that situation, right? For example, you are preparing for your JEE means in just just now you have started preparing for that, right? Okay. And someone is preparing for last 2 years. They know the basics, their basics are very good, their basics are clear, right? Now, from this 1 month, right? If you're not able to clear or you're able to clear, so then you will definitely go to the college, right? But for example, you're not able to clear in this 1 month. Will you remember this in next year or not? When you study something directly, for example, there is one kid who has not never studied thermodynamics in the entire life. This is the first time they are studying this. Tell me one thing, will they be able to understand this? No, right? They'll be like, ma'am, what you're saying? What are these diagrams, ma'am? Right? So, if you still have studied thermodynamics in 11th class, you have studied it somewhere in your life, then will be easy for you to understand what I am saying, right? Okay. So, that's the reason when you are studying something in small chunks, right? You're studying something, maybe after 2 months, you're doing the revision of thermodynamics. After 2 months, again, you're doing the revision. So, in small chunks, you're continuously studying, putting efforts there. So, that is something that will continue, right? So, you can reverse back, right? So, same thing I am telling you here, that for example, you take that big load on you in just 15 days, you are studying for JEE, right? Okay. So it's not like you will remember every single detail that I'll tell you in next year also or in the exam. It's not possible. But if you have studied in small chunks, you have somewhere studied thermodynamics in your life, right? In small chunks, you have studied organic, inorganic, right? Daily you are consistently like, giving the efforts, dedication you have. In that case, right, you will be able to reverse back. You will be able to think about, okay, this is what I have studied in 2 months back. I guess I remember that because that's my third revision. That's my fourth revision, right? Okay. So that is the thing that you can think about here, that when you have a big load on yourself, right? If I give it a big mass, a box, right? If I give it a box of mass M, what will happen? The pressure is going to decrease and piston is going to move here. Now, because of that sudden burden, it is not going to get reverse here. It will not move back here. So, it is a irreversible process. But if you give that, if you study in small chunks, right? Daily you study for 5 to 10 hours. Daily you are studying, right? In that case, in that small chunks, for example, you have a sand here. In small chunks, you are providing it the pressure, right? Now, it's not like suddenly it will decrease. It will decrease, then again it will decrease, and it will decrease in small amounts. That is the reason, right? It will be a reversible process because you have studied in small chunks. That is why you can also reverse that. The hard work that you have done before is useful to you, right? Okay, got it or not? Everybody in the comment section. Is that clear? What is reversible? What is irreversible? When you have a big block, right? Suddenly it decreases, then it's not possible to reverse it. When you are doing small steps, they are saying every step counts. When you are taking small steps, then you are also, if something bad happens, you are able to go back and make it correct, right? Okay, so here it is a reversible process. This is a life. This is exactly what we study in life, right? Now, in irreversible process, you will not use any differentiation. You will use delta. But in this case, because small steps you are taking, you will use D, right? And that's why you will do the integration. So the work done formula that you will calculate from integration, that is reversible, that you will calculate from delta, right? Change in pressure is delta P, delta V. That is nothing but irreversible process, right? Now, that is the first thing, which formula you will use, right? Second is, ma'am, how I will identify in the exam? In the exam, this particular statement, either they will give you a big box, a big block you had. They will not say it is reversible or irreversible. You will be able to understand that they are talking about irreversible process, right? Second hint that they can give you is that one-step process and multi-step process. One-step process means suddenly it will happen, and here it is happening in so many steps, right? If you talk about irreversible process, it is a fast process. You want to revise everything in 10 days. You have never studied anything in your life. You don't know what is chemistry, right? What is oxygen, ma'am? What is carbon? I don't know. But I want to crack JEE, right? Okay. So that is fast process you want to do. Here you are firstly making the basics. You have studied organic in 5 days. You are smoothly, you're studying everything. Today, ma'am will do thermodynamics. I'll study that in detail, right? So small steps you are taking. So slowly you are studying, but that is beneficial, right? Now, next very important thing is, very important thing, guys, that is irreversible process. They will say in the question, you will see at constant external pressure, and here it will be written at variable external pressure. Here the external pressure, the mass, the box is going to be constant. Beta, this thing will be written in the question. Whenever you see at constant external pressure, they are talking about irreversible process. Whenever you see at variable external pressure, they are talking about reversible process. Okay, understood? Yes. Now, next is zeroth law of thermodynamics. Never this question is asked to you, but still, because it is in your syllabus, I'll just tell you the definition here. It says that if two systems A and B are in thermal equilibrium with the third system, right, with the third system, then the system A and B will also be, that means if A is in thermal equilibrium with C, A is in thermal equilibrium with the, wait a minute, B is in thermal equilibrium with C. If these two systems are in thermal equilibrium with C, then A, B and C are in thermal equilibrium. That means if A is equals to B, or just simply beta, this we have done in mathematics also. A is equals to C, B is equals to C, then A is also equals to B. Okay, simple mathematics also we can say, simple thing, right? So that's why never ever this question is asked. Okay, now let us see from where the questions are asked, from these formulas. Okay, let's understand the formulas here. Yes, students, let's understand the formulas here. So first is for isothermal process for first law, right? So let's see first law, that is delta U is equals to Q plus W. So for isothermal, adiabatic, isobaric, isochoric, what is going to be the formula, right? So for isothermal, temperature is constant. That is the reason delta U is also equals to 0, because internal energy is a factor of temperature. If delta U is 0, we'll put it 0, then Q will be equals to minus W, right? Okay, so that is the formula for isothermal process. That is why they have said that heat given to the system, if you give the heat to the system under isothermal condition, is used in work done by the system. Very important. Beta, from these kind of theory points are asked to you, then you say, ma'am, what exactly, how can I predict that it will be on the system or by the system? See, they are saying heat given. Heat given means heat is given to the system. That means system is absorbing the heat. When system is absorbing the heat is positive. Now, if heat is positive, then W should be negative to make it equal. The sign should be equal. Na? They are saying it is equal. So that means W should be negative. Negative means work is done by the system. When the system has to do the work, then the system behaves negatively. So that is how from here, from this particular equation, these kind of theory-based statements can be asked to you. Assertion statements, reason statements, they can ask you statement-based question based on these kind of simple formulas, right? Okay. Next is adiabatic process. Same thing we will apply in adiabatic process, where heat energy is equals to 0. So if heat energy is equals to 0, can I say if this is 0, then delta U is equals to W adiabatic. Then delta U, internal energy change, is equals to work done on the adiabatic process. Work done on the system. That means if I am doing the work on the system, system is feeling positive, work is positive, brings an increase in its internal energy. What do you mean by that, ma'am? Work done on the system means this is going to be positive. But if work done is positive, that means delta U is positive. Delta U is positive. That means U final minus U initial is positive. It is greater than 0. Right? Okay. That means U final is greater than U initial. That means internal energy is increases. Is that clear to everybody? From these formulas, how the questions are asked on the theory statements. Okay. Got it? Is that clear to everybody? That work done is positive, or they will not say work done is positive. They will say work is done on the system. For option number 1, internal energy increases, it decreases, it remains constant. No, we can't predict that. These kind of question will be asked to you. Clear, bacha? Clear, everybody? Yes, everybody. This is a very, very important chapter of JEE. Okay, this is a very, very important chapter. Right now, next is for isochoric. Now, for isochoric, what will happen? Isochoric means delta V is constant, right? Delta V is 0. Volume is not changing here. Volume is constant. Now, we know, I told you that work done is equals to minus P delta V. If this is 0, then that means work done is going to be 0. Work done 0, let's put the work done 0 in this equation. Work done is 0 here. That means delta U is equals to Q. Now this Q, this is a very, very important formula, right? Very important formula. That change in heat energy, change in internal energy is equals to QV. Okay, remember this formula because we are going to make another important formula from this particular condition. Delta U is equals to QV. What is this V? That means heat energy at constant volume. Right? It's a very, very important thing. Now, let us see from here how theory questions can be asked. Theory question can be asked is, let's say your heat energy change is positive. That means this is also positive. So they are saying that heat energy given to the system. If I give the heat energy to the system, then only it will be positive. If you give me the money, then only I'll feel happy. If you take out the money, then I'll feel sad. Right? This is a law of human. Like this is how we human beings are. Right? So heat energy given to the system is happy. Arey, heat energy is given to me, I am happy, right? If this is positive, this will also be positive. So if delta U is positive, it is greater than 0. It means U final is greater than U initial. That means internal energy is increasing. That means constant volume increases the internal energy, right? Okay, it increases the internal energy, and work done here is 0. So no work is done in the isochoric process. So, bacha, what I am telling you, you don't need to cram these statements. Just remember the first law and just remember what do you mean by these isochoric processes. If you know the definition, you know this particular formula, easily you will get to these theory points. You don't need to cram these theory points, okay? Next is isobaric process. This is also very, very interesting, right? Okay. Yes, very good, Mohammed. Very good, very good. So everybody, green hearts in the comment section, right? Let's level up our energies, right? Okay. So isobaric processes for first law, right? Isobaric means pressure is constant, right? That means we know that work done is equals to beta what? Work done is equals to minus P delta V. Delta V. Pressure is constant does not mean work done will be 0, because work done is directly proportional to the pressure, not the change in the pressure, right? So that is why just put the value of work done, that is P delta V, right? Okay, so we know that because Q is nothing but we are talking about at constant pressure, so Q will be QP. Okay, so QP is going to be this is very, very important relation that we are deriving here. QP is equals to delta U plus P delta V. Now delta U is U final plus, basically it will be beta like this. Okay, I'll just write it here. It will be U2 minus U1 plus PV2 minus PV1. Okay, so you just put this here U2 and this is plus PV2, right, minus of U1 plus PV1. Okay, so this U2 plus PV2, remember one formula, H is equals to U plus PV. Okay, H is equals to U plus PV. This is a different question that we are going to do, right? This is a different formula that we are going to study from where the questions are asked. Yes, amazing, amazing. I just love the chat box here. Just love the chat box here, right? So this is going to be U2 and this. So this is nothing but H2 and this is nothing but H1. H2 minus H1 is delta H. So that's why we say that delta U is equals to QV, delta H is equals to QP. These two formulas are very, very, very important. Directly also they ask you these two formulas, guys. Directly also these two formulas are asked, right? Next is bacha cyclic process. Cyclic process. Talking about the cyclic process. So in a cyclic process, we know that all the state functions are 0. That means delta U is going to be 0 here. So if you put this here, delta U is equals to Q plus W. If this is 0, it will be Q is equals to minus W, right? So this is what we have written here, that Q is equals to minus W. Again, let's do the statement. Let's do the statement here. Let's do the statement. Let's say we are talking about positive means heat is given to the system. Heat is given to the system. And if this is positive, to make this full term positive, work should be negative, right? So that means work will be negative. Work negative means work will be done by the system, right? So that's why it is written here. The amount of heat absorbed by the system is equal to the work done by the system. Okay, by, why we have written by here and why we have written absorbed here, right? Okay, is that clear to everybody? Bacha, is that clear? Let's do some amazing formulas, some very frequently asked formulas of thermodynamics. Firstly, to basically work will be asked either from isothermal or from adiabatic. Why? Because in both the cases we have reversible and irreversible. I'll tell you, in isothermal case, in isothermal, what is the trend? Okay, the trend is in isothermal they will ask you work, and in adiabatic they will ask you the final temperature. Okay, so that's why firstly we are going to learn about isothermal, right? Reversible, irreversible, and other works also. Adiabatic work we will learn after we study enthalpy and heat capacity. Okay, understood? So let's revise this thing also. Irreversible work. Okay, let's revise irreversible work. Everybody, irreversible work is done in one step or multiple step. Everybody, let's see. Let's see. Thank you so much, Sian. So irreversible work is done in one step or the multiple step. I am waiting for your answers in the comment section. Irreversible work is done, and our teaching is excellent. Then why students have not liked the session? More live watching than the likes on this video. And that's not a good thing. Everybody, right? If you appreciate what I do for you, preparing everything for you in advance to save your time, right? Continuously speaking, right? I am feeling literally my voice is gone, right? But still I am continuously speaking at this time, right? Only for you guys, right? Only for you, right? On Sunday also I am here, right? Okay, yes, it is a one-step process. So one-step process, it involves integration or not? Everybody, will it involve integration? One step, a big change will happen here, right? A big change will happen here. So whatever, see, if you're in the, for example, in the morning, someone tell you, "Arey, this question will surely be in the exam." You will not even think about it. You will just learn the concept. Okay, this is A, B, C, D, A, B, C, D, A, B, C, D. So this is going to be the answer. Okay, I'll just vomit it out in the exam, right? So it's the same thing. It's not like ki after, even if that question appears in the exam, after the exam, you will not remember that question because it's a big step that you have taken, a fast step that you have taken at a big change that you have done. So here we are going to talk about delta, right? Not D, right? So it will be work done is equals to minus P delta V. P, pressure will be the external pressure here. Right, pressure guys, it will be the external pressure here that will be applied, that will be given to you in the question. So it will be V2 minus V1. What is V2? PV is equals to nRT. Here I have written PV is equals to nRT. That means P1 V1 is equals to nRT. Because temperature is constant here, so temperature is T only, not T1 or T2. So V1 is equals to nRT by P1. V2 is equals to nRT by P2. So I just put the value, take nRT constant. So answer will be this one. And this is the formula that you are going to use in irreversible isothermal process. If you don't want to cram this formula, nobody is asking you to cram. Just remember minus P delta V because it is irreversible, so it will be delta V. Just do this derivation. It's just a task of 1 second, right? So you don't need to cram those things which are not even needed, right? So use this formula for irreversible isothermal process. Now, reversible process. Reversible process, we can revise things again and again if we have studied at a very peaceful time. Now what you are studying, Every single thing I am telling you, right? If I tell you all these things in just 1 hour before the class, you'll be like, I don't remember anything after the exam, ma'am. Now you will remember things after the exam also, because you have studied this when your mind is not under stress, right? So it is a small things you are studying, ma'am. Day before we have studied equilibrium, now we are studying thermodynamics, small steps. So D means small things we are doing. So whenever you have differentiation, you will integrate it, right? Here I will not ask you to remember this derivation, right? Okay. No, don't remember and do the derivations, right? Just remember this formula. Just remember this formula, guys, because in derivation, this much derivation, na, it will take time, and what will happen in the exam, you will do the derivation only. You will not be able to solve the questions, right? We have to do the calculations also, है ना? It's not like in maths you won't be doing calculation. You have maths, you have physics where calculation is needed, so you need to save your time, right? Okay, so that's why just remember this thing, that is work done is equals to, if they give you volume V1 and V2, if they give you final and initial volume, then answer will be minus 2.303 nRT log V2 by V1. If they give you pressure, beta, this is very important. In terms of volume, it is V2 by V1. In terms of pressure, it is P1 by P2. Right? It is P1 by P2. Here it is V2 by V1. That is final by initial. Here it is initial by final. Okay, it's a very important thing where students get confused. Okay, that's why I am just telling you that this is V2 by 1. 21. In volume, it is 21. V21. Just remember volume 21. V21. Okay, understood? Pressure, it is opposite. Got it? Yes, everybody? Chal. Next, isobaric, isochoric, cyclic is very simple, and very rarely they will ask you this, है ना? Because they want to ask tough things to you, not easy, right? Okay, chal. Now let's do isobaric process. In isobaric process, you have pressure is equals to constant, right? Isobaric pressure is constant. So simply the formula will be W is equals to minus P delta V. Volume will be given to you, final and initial volume, simple, sorted, no idhar udhar ka garbage, right? Okay, very simple thing. Now next is isochoric. Isochoric is when the volume is constant. Now when the volume is constant, in that case delta V will be 0. When delta V is 0, work done is 0, then why to worry? We have done. In isochoric process, work done is 0, right? When volume is constant, work done is not taken. Work done will be 0 in that case, right? Okay, ma'am, let's talk about cyclic. Now in cyclic process, you will say, ma'am, she has told opposite, ma'am, right? Okay, so in physics, it is opposite. In chemistry, it's opposite, right? Okay, so here clockwise is the negative work done, and anti-clockwise, again because of the sign conventions, right? It's not like physics is right, chemistry is wrong. It's basically the sign convention and the formula. That's why the answer is coming out to be different, right? So that's why don't get confused in physics and chemistry. What is applied in physics, applied there. What is applied in chemistry, applied it there, right? So I think chemistry scientists and physics scientists should have a get together and just solve this issue here, as students are getting confused here, right? So cyclic process, right? There should be only one thing, one sign convention, even if it is physics or chemistry, but there is actually one proper reason behind that. Because in physics, we talk about machines and macroscopic things, and in chemistry, we talk about microscopic things. So that's why it is done here, right? So now, whenever you have work done is the area enclosed here, area enclosed in that loop, that is the work done, right? If it will be positive or negative, that will depend on the clockwise. It will be positive or negative, that will depend whether it's clockwise or anti-clockwise. Now, as you can see, if it is clockwise, it will be negative. If it is anti-clockwise, it will be positive, right? Okay, anti is positive here, anti is positive here. Okay, okay, yes. Now, next is, guys, open vessel. So this question is very simple. Trust me, this has been asked. So that's why. Basically, if you talk about the open vessel, right? If you talk about the open vessel, again, work done is equals to minus P external delta V. Okay. or you can also take it as work done is equals to, we know that PV is equals to nRT, right? So that's why delta N, because if it is an open vessel, reaction will happen, some gaseous molecules will be eliminated, right? Some will stay. So that's why it is minus, instead of PV you have written nRT. Number of gaseous moles will change because it is a open vessel, so it is delta NgRT. Now students, remember this thing, if you see a reaction and they say that this is an open vessel, this is the reaction, what is the work done, and they have given the work done in terms of like this, work done is equals to minus 2RT, work done is equals to minus 8RT, like this they have given. That means they are talking about this particular formula. So delta Ng will be applied whenever you have a chemical reaction already given to you, right? So here, for example, this is the example that I have shown. They are saying that this is an open vessel reaction and you have 2NH3 give rise to N2 plus 3H2. Now they are asking you whether the work is positive or negative, or work is done by the system, or they can ask you expansion is happening or compression is happening, or what is the work done. All these things they can ask you, right? Calculate, because reaction is given to you, calculate the value of delta Ng. It is 4 product minus reactants, because all of them are the gases. But all of them are gases, H2, N2, NH3. So it is 4 minus 2, that is 2. So work done will be equals to minus of 2RT. Minus of 2RT, that is the work done. That means work done is negative. That means work is done by the system. When work is done by the system, expansion will happen, or you can say heating. We can also they can also ask you what will happen in the options. They can give you cooling, heating, nothing. This all they can give you, right? Okay, got it. Ma'am, it's about in physics. Is it correct, ma'am? Beta, correct are both. Physics and chemistry both are correct only. It's just that sign conventions are different, right? That's why the formula is different. Answer you will get the same in physics and chemistry, right? Okay, just the way of solving it is different, right? Okay, is that clear? Now, to understand adiabatic process, we have to go through some formulas of enthalpy, right? So let's discuss about enthalpy. Enthalpy is delta H, that is heat change in a product minus reactants. So this is a very, very important formula. In your books, you will see delta H is equals to delta U plus P delta V. Okay, but the correct way of writing it is, it's not U, it's with a V, okay? It's V. Okay, so correct way of writing it is correct way of writing it is delta PV. If they have given that pressure is constant, so it will be P delta V. If they have given volume is constant, so it will be V delta P. Okay, so that's why I have written it like this. Now we know that PV is equals to nRT. PV is equals to nRT. If you replace this with nRT, R and T, that means gas constant and temperature are constant here. So it will be delta NgRT. Now, when to use this formula? Ma'am? That is the question. Okay. The problem is, ma'am, when to use which formula? That is the main problem. Right? Okay. So how you will solve this problem? We'll just say that whenever you have a chemical reaction, in that case, you will use this formula. Whenever they have given you, this is the chemical reaction, that means this formula will be used, right? Okay. If they have given you pressure is this, volume is this, change in volume is this, pressure is this, change in pressure is this, volume is this, then you will use these formulas. Okay, got it? Yes, everybody. So this will be used when you have chemical reaction. You can write here, when you see chemical reaction in question. When you see chemical reaction in question, then you will use this particular formula, right? Okay. But even I don't know what is the class duration, right? But I think we are about to finish this only. After that, we'll do questions, right? Okay. Now, delta H is positive. That means energy is required, energy is absorbed. It is endothermic process. When delta H is negative, energy is released, right? Energy is given out, right? That is called exothermic process. Now let us understand heat capacity, beta. This is a very important concept, okay? A very important concept, heat capacity. Monatomic, diatomic, gamma value, right? Degree of freedom. From these, the questions can be asked, okay? So this concept is a very important concept, right? Okay, yes, okay. And it's a simple concept also. If you understand the formulas, it will be simple for you. First thing is, ma'am, what is heat capacity? Heat capacity is when you have the change, that 1 degree change in that. If you say that you, how much, when you are increasing the temperature by 1 degree, how much heat change you have, that is called the heat capacity, right? With that 1 degree change, how much heat you are still left with. That is why the formula of heat capacity that is mentioned by C is Q by T. That means with this particular temperature change, Q is the heat energy which will come out to be C, right? Okay. So, first thing is Cp, other is Cv. Cp is at constant pressure. So, when you have P here, you will also put P here. Hai na? So, and this will be delta because it is the change. So, it will be Cp is equals to Qp by delta T. It will be Cv is equals to Qv by delta T. What is Qp? What is Qv? What is Qp? What is Qv? What is Qp? What is Qv? Qp is, everybody, Qp is delta H. Okay, we have done this before, right? Qv is nothing but delta U, and this is a very important formula again, students, that Cp is equals to delta H by delta T. Cv is equals to delta U by delta T. But ma'am, in my book, it has written something else. I'll tell you what they have written. Now, this Cp is basically for N moles. This Cv is for N moles. In books, na, they have written something in bracket. That's why students get confused here. Cp and Cv is for N number of moles. If you are saying that I want to calculate it for 1 mole, that is called molar heat capacity for 1 mole, and in that case you have to divide the Cp or Cv with N number of moles, right? Okay, so here it will be Cp is for N moles, but Cpm, that is the molar heat capacity at constant pressure. Cvm, molar heat capacity at constant volume, right? Now, this molar heat capacity is defined for specific 1 mole. That's why we have divided it for N, right? We have divided it by N, that is the number of moles. Here also I have divided by N. Now, this is the formula that you must have seen. Now, this is the formula that is very famous. Just replace this here. This will be delta H is equals to N delta T. Usually, in most of the books, or in especially in, I think, NCERT also, what they have mentioned, in NCERT they mentioned delta H is equals to NCP delta T. In the bracket they have written Cp is for N moles, for 1 mole. Right? Instead of learning it like this, learn it like this, that delta H is equals to NCPM delta T. Okay? Delta H is equals to NCPM delta T. Delta U is equals to NCVM delta T. It's a very important, very important formula, right? Okay, very important formula, right? Okay, got it, guys? Yes, delta H and delta U in terms of heat capacity. If you talk about delta H is related to heat capacity at constant pressure, and delta U is related to heat capacity at constant volume. As it is, you have to learn this formula, right? Specific heat capacity is not that important, right? Okay, usually molar heat capacity they will ask you, but still specific heat capacity is when we talk about 1 kilogram. Okay, so when you talk about 1 unit mass, right? Okay, to increase the temperature by 1 degree Celsius, right? So that's why we have divided it by the mass. Okay, that's why we have divided it by the mass, that is M. There we were talking about 1 mole, so that's why we have divided molar heat capacity with N moles. right? Okay. Now these formulas, right? Okay, just remember these formulas in terms of degree of freedom. I'll also tell you what is degree of freedom. Degree of freedom, right? Okay, that is represented by this F, right? We will learn the degree of freedom, don't worry, with the help of examples. First of all, you need to understand these formulas. That is gamma is equals to Cp by Cv. That is the Poisson's ratio. Gamma is equals to Cp by Cv. Ma'am, how you will calculate Cp? Cp is equals to, how you will calculate Cp and Cv? Cv is equals to degree of freedom by R, multiplied by R by 2. Cp is equals to R plus Cv, because Cp is equals to R plus Cv. Okay, understood? Understood, guys? Cp is equals to R plus Cv, right? Just remember this formula, and from this formula also I have something very, very interesting to tell you. Something very, very interesting to tell you. I'll just write it like this only. This is Cpm, this is Cvm, this is also Vm, this is also Pm, this is also Vm. Why I am telling you that? Because all together we are talking about molar. Okay? So molar heat capacity of at pressure divided by molar heat capacity at constant volume. There is some reason behind why I have written MMM, right? See, Vm is equals to freedom Fr by 2, Fr by 2, Cpm is equals to R plus Vm. Reason is because Cpm minus Cvm is equals to R. But if you talk about, ma'am, then what is the relation between Cp and Cv is equals to R? Ma'am, this is written in NCERT, ma'am. This is written in NCERT, ma'am. How can you say this is the correct answer? This is written in NCERT. But in NCERT, na, they have also written it is for n. N number of moles. They have also written that thing there, right? So when you are not going to write anything in the bracket, right? So you have to just remember the formula directly with the help of what denotions that you have given it, right? So we know that Cpm, Cvm is for molar heat capacity. That is why Cpm minus Cvm is equals to R. But for Cp and Cv, it will be Cp by, wait a minute. This will be, when I multiply this by n, it will be Cp by n. So if I talk about Cp minus Cv, then Cp minus Cv is equals to n into R. Why? Because then I multiply this by n, I divide this, I also multiply this by n, I also multiply this by n, right? So that means I have Cpm is nothing but it is Cp by n. Cpm is nothing, it is Cp by n only. So it will be Cp by n, it will be Cv by n, n will cancel out each other. It will become Cp minus Cv is equals to nr. Got it? Why I have written these two formulas here, right? So here it will be Cpm is equals to R plus Cvm. Got it? Now, next is, ma'am, how this is beneficial for us. So what kind of questions they will ask you, right? This is how they will ask you the question directly with the help of table. Just remember this thing, right? Formulas, remember these formulas. If you remember this formula, you don't need to remember this table, because here just it's a matter of I'll just teach you, I'll just understand what I'm telling you, right? Monoatomic means when there is only one atom in that gas, like helium, neon, argon, right? These things, right? Now, monatomic gases have 3 degree of freedom. So, degree of freedom is also another concept. It has translation, rotation, and it has vibrational motions, right? You don't need to get into that, right? Because right now is not the right time to get into that, because they are not going to ask you those things in chemistry. They will not ask you those things in chemistry, whether it's vibrational, translation, what kind of motion. But yes, here the 3 degree of freedom are due to translation only. But they will not ask you this, right? So just remember that how many degree of freedom it has. Monatomic gases has 3 degree of freedom. Diatomic gas, diatomic means H2, O2, N2, these gases, or polyatomic gases, which are linear. Like carbon dioxide is a linear gas, but it is polyatomic, right? So polyatomic linear gases, they will have 3 plus 2, that is 5 degree of freedom. 3 is translational, 2 is rotational. Okay, vibrationals we don't consider here. We don't consider vibrational degree of freedom here, right? Non-linear polyatomic, like you have SO2. SO2 is not a linear molecule, it is a non-linear molecule. So non-linear polyatomic gas, it will have degree of freedom 6. Just remember the degree of freedom and remember these formulas, right? Now we know that Cv is equals to Fr by 2. Just put that value here and you will get the value of Cv here. Cp is equals to Cvm, Cpm is equals to Cvm plus R, right? Just put this value here and you will get the value of Cvm, Cpm, Cpm, Cpm. Now gamma is equals to Cpm by Cvm, Cpm by Cvm, and that will be, just divide these two things, you will get it as 5 by 3, this will be 1 by 1.4, and this will be 1.33, and this is the direct question that they can ask you, that what is the relation of Poisson's ratio or gamma value of monatomic, diatomic and triatomic or polyatomic. So monatomic has maximum 1.6, then 1.4, then 1.3. This relation can be directly asked to you. They can also ask you, they can give you one example, what is the value of gamma. They can give you this, ask you what is the value of gamma. They can also ask you Cp, Cv value, but that is rare to ask. Mostly they ask gamma value or the relation or the increase or decrease in the gamma values of monatomic, diatomic or triatomic gases. Right? Okay. Got it, students? Yes, everybody. The most irritating question that I have been asked in the class is, ma'am, when the class will end? Right? Okay. The most irritating question that is by the students. If someone asks me what is the most weird and irritating and stupid question that students ask is, ma'am, when the class will end? Arey yaar, do you want to know, do you want to gain some knowledge or not? Or just want to, ma'am, I want to be an engineer, ma'am. But ma'am, when my manager will ask me, na, then I'll just go to the office and I'll just open the door of manager and I'll say, when we are going to leave, when we are going to leave, then they will be like, please resign and go, right? Okay, so stop doing these things. You guys are mature now, right? You should know that some very important chapter is going on, right? Let's stop asking again and again, when the lecture will end, when the lecture will end, when the lecture will end, right? If I am singing here, dancing here, then you can ask, ma'am, when you will stop all this and please teach us, or ma'am, go. If ma'am is teaching something valuable, then stay there. You are getting knowledge for free. Be happy about it, right? Don't take things for granted. Be happy about, thank you, ma'am. Thank you, ma'am, so much, ma'am. You are teaching us for free, ma'am. Yes, ma'am, teach more, right? That should be the attitude. Gain knowledge, right? Okay, chalo. Now, guys, let's talk about adiabatic. But before that, let me see how much beta half to we have done. Very few, 3-4 pages we are left with, right? 3-4 pages beta we are left with, right? 3-4 pages more, 3-4 pages more formulas. After that, we will do the previous year questions. Okay? Yes? Okay, Ji? Okay? Yes. Hello, hello, hello. Stopped, ma'am. Stopped. Arey, thank you, thank you, thank you. Now. No voice, ma'am. Now voice. Now ma'am has voice. Right? Now ma'am is audible. Right? Now ma'am is audible. Now I will see. Yes, ma'am. Now okay, ma'am. Yes, ma'am. Voice, ma'am. Yes. Okay. Chalo. Now we have adiabatic process. As I told you, we will learn about adiabatic process after we learned heat capacity. Now let's talk about adiabatic process. Right? Why I taught you heat capacity and enthalpy before that, because to understand heat capacity, you need to know what is delta H, right? To understand adiabatic work done, you need to understand what is heat capacity, right? Now, don't get into the derivation of these formulas. You don't need to remember that, right? You are preparing for a competitive exam. If it would have been a subjective question, then I would have told you, right? Now, simply just remember this formula, and this formula is applicable both for reversible and irreversible. And irreversible, ma'am, what you are saying? You were to telling, ma'am, for reversible and irreversible, the formula is different. Now you are saying the formula is same. Ma'am, how can you say that? Right? Okay, I'll tell you why I'm saying that. Because the way T2 is calculated is different for reversible and irreversible. So the formula that we'll use to calculate the value of T2 and then put the value of T2 here, that will be different. Okay, that means final temperature will be calculated in a different way. So if you talk about a irreversible process, then in that case, this is the formula that you are going to use for calculating the value of T2. It's a very, very important thing. Most of the students, they are confused that, ma'am, what is the difference? What is the formula difference here? Because the formula is same for work done for reversible and irreversible. Now, if you talk about, they are asking you that what is the final temperature, or even if they are asking you the work done, firstly, they will not give you the final temperature. They will ask you the final temperature, or they will ask you the work done. You have to calculate the final temperature differently for reversible, differently for irreversible. Then you will put here, then you will get your answer, right? So now let's see this here. If you talk about, if you want to calculate the value of irreversible, one step, they will say constant external pressure. These are the hints that they will give you, right? Here, final temperature T2 will be calculated by this particular method. That is, this is T2, right? This is T1 by P1, T2 by P2. This will be given, this will be given, this will be given, this will be given, given. This will be given, this will be given, this will be given. And you have to calculate the value of T2 from here, right? If they actually want to take some revenge from you, they will ask you this question, right? Okay, why? Because it's not first of all, many students don't know that this is the formula that they need to apply. Then even if they know the formula, this is the formula that they need to apply, then they get confused in the calculations. That is why this is a very, very tricky question. If they want to ask you in thermodynamics, they will not ask you something out of the world. If they ask you this, you will feel like this is out of the world question, ma'am. It's very tough, right? Because you will get confused in doing this. That's why practice is very important. After this, after when I do the previous year question, you also need to do the practice yourself also, right? Okay. Now, ma'am, if we have reversible process, then for a reversible process, if you have a reversible process, I'll just write it here. If you have a reversible process, very rarely they will ask you, right? For reversible process, you will apply this formula, that is TV gamma minus 1 is constant. They will give you the value of gamma. Let's say they have given you, this is I am saying, if they ask you very difficult question, if they are asking you, then they will do this, okay? They have given you, it's a monatomic gas. You know that monatomic gas, gamma value is 1.6. So you can put the value, it will like this, T1 V1 is equals to T2 V2. Here it is gamma minus 1, here also it is gamma minus 1. Gamma value you already know. What they will do here, they will give you the value of V2, they will give you the value of V1, they will give you the value of T1. Gamma will also be given to you. You have to calculate the value of T2. Right? Okay. This is the kind of thing that they can ask you. They can also give you like this. P1 1 minus gamma, T gamma is equals to P2 1 minus gamma, T 2 gamma. Here also they will give you that what is the value of gamma. It is a diatomic gas. It is a triatomic gas. Right? They will give you the gas, only then you will know the value of gamma. Then you will solve it here. Got it, guys? Okay. Is that clear? Right? Is that clear, students? It's a very, very important concept. Let me know in the comment section if that is clear to you or not. Right? I have tried my best to make it as simple as possible. Adiabatic process, guys. Again, I am telling you, adiabatic process. This is the formula of work done. Right? Very rarely they will ask you the work done. But to answer the work done, they will not give you the value of T2. You will see the question, never they will give you the value of T2. Otherwise, it will become very, very simple question, right? They will not give you and they will expect you to find the value of T2 using either this formula or this formula. This formula is used when irreversible. This formula is used when you have reversible process. Okay, that is clear. If that is clear, green hearts in the chat box for this one, right? Okay, green hearts in the chat box for this one. Okay, now everything else is simple only. If you talk about free expansion, right? In free expansion, work done is 0, right? Q is 0, heat energy change. There is no heat energy change in free expansion. Now, if Q is 0, W is 0, in that case, delta U is also 0. That's why we can say all terms of first law, beta, all terms of first law is equals to 0. Right, that's an important factor that they can ask you out of the which process all the factor of all the terms of first law is 0. That is free expansion. Okay, now next is entropy. Entropy is basically randomness. Okay, randomness. So when you have recess in the class, what do? Randomly someone is going here, someone is going there, right? Randomly you are doing things. Right? When teacher is there in the class, then you're sitting like this. So this is entropy. Disorderness is increasing. Now, from entropy, mostly they don't ask you the numerical. Mostly they will ask you either question like this based on the theory, or they will ask you directly the question, directly the formula, right? Directly formula they will ask you. Let us see firstly, what is the increase or decrease in entropy? How they can ask you. First is between graphite and diamond. Graphite has more entropy as compared to diamond. Diamond has a, if you talk about graphite has a layered structure, so disorderness is more. Diamond has a network structure, so it is a compact structure, that is why disorderness is less, entropy is less. Next is precipitate formation. If you talk about precipitates are getting formed, there was some solution, liquid to precipitate, liquid to solid it is getting converted to. That means molecules are getting closer, so entropy is decreasing here, right? Dissolution, you have to imagine everything. Dissolution means you have sugar, it is getting dissolved in water. When sugar is getting dissolved in water, what is going to happen? What is going to happen? Entropy of that sugar that was earlier a solid, now it is mixed in that solution going here and there. So entropy increases. Rusting of iron. Iron is getting rusted, right? Iron is getting rusted here. Entropy of rusting, because iron is getting converted to a different oxidation state, right? If you see the rusting, there is very, what thing I can say, when you see a iron, right, simple iron, then it is a structure which is layered. Rust is not layered structure, right? You will see it is a very rusty thing. We can say that it is very disorderness type of situation you will see in rust. That is why entropy increases there. Boiling of egg, that's a very, very important concept. That boiling of egg, usually you will think, ma'am, liquid is getting converted to solid. So entropy should increase or decrease. Ma'am, liquid is getting converted to solid. Ma'am, molecules are coming closer to each other, ma'am. Ma'am, molecules are coming closer to each other. Disorderness is decreasing. Ma'am, it should decrease, right? That will be in your head. But in reality, entropy increases because of denaturation of protein. They will not ask you in detail. You are not a NEET aspirant. So you just need to understand that because of denaturation of protein, entropy will increase in boiling of egg. Next is stretching of rubber band. So you have a rubber band, what you will think? That okay, earlier the molecules were closer, now the molecules are far away. Molecules are far away. That means entropy should increase. But in reality, what is happening? Earlier the molecules were like this. Molecules in the rubber band were like this. Okay, in the rubber band, the molecules were like this. Okay, this, like this, randomly distributed. But when you stretch it, okay, I'll just show you. When you stretch it, now what will happen? Molecules will be perfectly aligned here. Molecules will be perfectly aligned here. That is why entropy will decrease here. Okay, that is why entropy will decrease, not increase. Got it? Yes, everybody. Chalo. Disorderness is not increasing, it is decreasing only. It is getting in the order. Right? Okay? Yes, students? Mohammed, then you need to study that denaturation of protein in bio in detail. Right? Okay, everybody, let's do this. Now, this is the formula of entropy. Just remember this formula, these two formulas, and every other formula will be generated from this one only. So this formula is delta S is equals to n CVM natural log of T2 by T1, nR natural log of V2 by V1. This is for irreversible adiabatic process. From this only we will derive all the other situations. Irreversible adiabatic processes, in case of volume you have this formula, in case of pressure you have this formula. Right? Now, next is, ma'am, what about reversible adiabatic process? Now, guys, if you see the definition of entropy, it is Q reversible by T. Now, adiabatic process, heat is 0 for reversible, right? Heat is 0 for reversible, and reversible only you have to put here. In adiabatic, heat is 0, right? That I know. But in the entropy formula, you have to put the value of only Q reversible, not Q irreversible. That is why for irreversible you have this formula, but for reversible it is 0. Right? So for reversible it is 0, for irreversible these two formulas. Now, if you have isothermal, from this formula only, just erase this and this one. That will be the answer. nR natural log V2 by V1, nR ln V2 by V1, nR ln P1 by P2. For isobaric, see the formula which has pressure. Baric na, see the formula which has pressure. Baric means this will be 0. So put the value as NCPM natural log T2 by T1. NCPM natural log T2 by T1. Isochoric, put this value as 0 because V1 is equals to V2 now, so this will be 0. Right? So NCVM natural log T2 by T1. NCVM natural log T2 by T1. So you just have to do these two formulas. Rest of the formulas you can derive from that one. Right? Okay. Right? Because of symmetry of rubber band, because symmetry is increasing, disorderness is decreasing. That's why in rubber band entropy decreases. Right? Okay. Understood? Now, very, very important equation, that is Gibbs-Helmholtz equation. In Gibbs-Helmholtz equation, what you need to understand, that is delta G is equals to delta H minus T delta S. Right? Gibbs-Helmholtz equation, they can ask you whether this is spontaneous, non-spontaneous. This is what they will ask you. So, if you talk about when your delta H is negative, when this is negative, and when T delta S is positive, this is positive. That means always and always this whole value is going to be negative. That means in any condition this is going to be a spontaneous process, because for a spontaneous process delta G should be negative. Right? Next is when delta H is positive, if you say this is positive, right, and this is negative, negative means this whole term will be positive. Always and always the whole term will be positive. That means always it is going to be a non-spontaneous process, right? Next, if this is negative and this T delta S is positive, now to make this spontaneous, wait a minute, this should be negative, na? Now this is negative. Now this whole term will be positive. That means, right, this will be negative. It will be like this, right? Now, in this case, if delta H is greater than T delta S, only then this whole term will be negative. That means only then it will be a spontaneous. So, delta H should be greater than T delta S. Now, next is, if this is positive, right, and this is also positive, that means this is positive, this is positive. In this case, T delta S should be greater. T delta S should be greater than delta H, so that the whole value will occur negative. That is spontaneous process. Okay, spontaneous process. Okay, guys. Chalo, last slide of this one that we have. Thermochemistry. Thermochemistry theory, you don't need to understand about thermochemistry. Reason being, what I'll tell you in the theory, right? Okay, so theory, if you talk about the summarized part of this theory, summarized part is that if hint is given to you about bond energy, if they have given, calculate, they have given the bond energy, let's say they have given some reaction, right? They have given the bond energies of different reactants and products, right? They are asking you whatever they are asking you, delta H reaction, they are asking you full reaction. There will be reactant minus product, right? But if anything else is given to, they are saying enthalpy of formation, enthalpy of combustion, anything else is given to you, then it will be product minus reactant, right? Okay, understood? If bond energy, this you will understand when I'll do the question, then you will understand this better. Better tell me, is that clear? Is that clear? Okay, guys, is that clear? Now, shall I start with the questions? Everybody, shall I start with the questions now? Previous year questions of thermodynamics, right? Previous year questions of thermodynamics. Now, let's speed up the process here, right? Okay, are you all ready for that? I want to see the chat filled with energy, right? Yes, students, I want to see the chat filled with energy. Everybody here. I want to see your energy. Yes, ma'am, start. So let's start and see. First thing is calculations. If we start doing it, will take it 1 to 2 hours, right? So I'll just tell you what is the process, what formula to apply, right? Rest of the thing you will do on your own, but I have taken all the kind of questions that can be there, right? Okay, so let us start it with the first question on your screen, that is, choose the correct option for the free expansion of an ideal gas under adiabatic condition. Now, guys, adiabatic condition means delta U is 0. So, that means C is not the correct answer. Delta T. Okay, wait a minute. Free expansion, na? They are asking you the free expansion also. Free expansion means delta U will be 0. Work done will be 0. Q will be 0. This also we have done just now, free expansion. So, everything will be 0. Q is 0, delta T is 0, delta U is 0. That is why delta T will also be 0, right? So, answer will be D is the correct answer. So, answer will be D is the correct answer here. Okay, yes, everybody. Chalo. Next question on your screen we have, for a certain reaction at 300 Kelvin, K is equals to 10 meter, then delta G for the reaction. T is equals to 10 meter or what? K is equilibrium constant, no? It will be 10, right? Then delta G naught for the same reaction is given by this. Okay. So, just have to apply the formula of K and delta G naught, which are, this will not be 10 meter, okay? Meter, equilibrium constant will not be in meter. Okay, so this will be 10, right? Okay, so just apply the formula, everybody in the comment section. What is the formula of delta G and K? This is from equilibrium, right? This we have done in equilibrium also. Delta G is equals to, guys, everybody, delta G is equals to, equilibrium is what? Minus RT ln K. Isn't it? Yes, everyone, isn't it? Now, can we write it in this 2.303 RT log base 10 of Kc, right? They are asking you certain reaction at 300 temperature. They are asking you the delta G naught value minus 2.303. Who are saying, ma'am, we have not done it today, beta. We have done this in equilibrium chapter. This equation we have done it there. This formula we have done it there. This will this will be 300 and this is log base 10 of this is 10 only. Log base 10 of 10 is 1 only. So it will be minus 2.303 multiplied by 8.314 multiplied by 300. And here you will get the value of delta G naught. Okay. With this you will get the value of delta G naught. One student is telling me that, ma'am, 6 is the correct answer. 6 is the correct answer. You have to calculate this in kilojoules. Okay, you will get the value in joules. You have to convert it into kilojoules. Right? Okay. So, you'll just multiply. You will get the value in joules. Then you will convert it into kilojoules. Right? Okay. So, simply do the calculations. Now, next is if 3 moles of an ideal gas at 300 Kelvin expand in isothermally is okay, 3 moles, number of moles is given to be 3, ideal gas is given to us, expand isothermally, that means temperature is constant, from volume is given to us against a constant. Now beta, tell me this thing, is this reversible or irreversible? Many students are confused here that which formula to apply. But I have given you a very simple trick. You need to tell me. Firstly, now let us see. Okay. Beta, a lot of concepts are there. So at constant opposing pressure, right? Like you can see 70-80% of the lecture we have completed. Just 20% we are left with. Right? Okay. At constant opposing pressure, is this reversible or irreversible? Yes, very good. I'm so happy to know that. Yes, this is irreversible process, ma'am. And in irreversible process, which formula to use? Whether to use integration formula or to use that delta formula. Which formula to use? Delta or integration? Just tell me that. Which formula to use? Delta or integration? Delta or integration? Beta, trust me on that. I don't remember physics exactly, the thermodynamics of physics, right? But yes, obviously the concepts will be same, but the sign convention and some things are different there, right? Okay. Now, it is integration. Integration means small steps. When you have delta, that means big step. So in irreversible process, irreversible means whatever you have studied, you won't be able to recall it back. When you have studied, like for example, you take in 10 minutes, ma'am, thermodynamics I'll study. Will you remember anything? No. If you give it 3-4 hours, then definitely you will remember. So when you take a big chunk and you study that, then what will happen? It will be irreversible. That means delta, big part we will do here. So delta formula we will use here. Right? Okay. Now V1 is given to you. V2 is given to you. Temperature is given to you. Right? Expand isothermally from this to this against this of pressure. P external is given to you. Right? Then the amount of heat transferred is equals to, beta, just apply this formula here. Right? Wait a minute. They are asking you the amount of heat transferred now. So basically, if you calculate the value of work done, we know that delta U is equals to Q plus W, right? We know that for isothermal process, this is going to be 0. So Q is equals to minus W. Heat transferred, they are asking you, heat transferred will be minus of W. So firstly, calculate the value of work done, then just take the minus of it, you will get the heat transferred, okay? So calculate the value of work done here. Work done is equals to minus P external for irreversible minus P external delta V. Delta V is given to you here. That is given to be, delta is given to 45 to 30, right? So we have put 45 and 30, right? Okay. And what is P external? P external is given to be 80 kilopascal na, so converted into Pascal. This is Pascal, okay? Converted into Pascal, right? Okay. So answer you will get is, this is the work done that you will get. And Q is what? Q is minus of this, right? So Q will be positive, right? Okay. So W is coming out to be minus of 1200. So Q will be minus of W. Q will be equals to plus 1200. That is, this much heat is transferred here, right? Okay. Heat they are asking you, they are not asking you the work done. So work done will be positive. That is this one. Okay. Chalo. Next question, beta, that is given to you. That is, so the main thing was not calculations and all. Main thing was not even this thing. Main thing was to understand whether we should apply integration formula or we should apply this delta formula. Most of the students, they get confused there only. That's where they ruin their question, right? Okay. Now, next is for a certain thermochemical reaction. Now, they are asking you half of this we are left with. For a certain thermochemical reaction, M is given rise to N at temperature 400 Kelvin. Delta H is given to be this. Delta S is given to be this. They are asking you the equilibrium, log equilibrium constant is what? Okay. Okay, simple. See, from delta H and delta S, we will firstly calculate the value of delta G from Gibbs Helmholtz equation. Then we will apply this formula, right, of minus RT ln K. Then we will calculate the value of this equilibrium constant. Is that clear to everybody or not? Guys, firstly what we will use, right? Firstly, beta, what we will use. From first to see what they are asking you. They are asking you equilibrium constant. We know that equilibrium constant is linked to not entropy, not enthalpy. It is linked to Gibbs free energy. That means we need to calculate Gibbs free energy firstly. है ना? Now, Gibbs free energy will be by Gibbs Helmholtz equation, that is delta G naught is equals to delta H naught minus T delta S. Minus T delta S. So, answer is going to be, this is going to be, just put the values here, do the calculation. So, I'll just do it here only. I'll just divide it into 2 pages, right? So, it will be delta G is equals to delta H minus T delta S, that is Gibbs Helmholtz equation. Delta, this is going to be 77.2 minus 300, and this is, okay, this is in kilojoule. So, convert it into joule, right? Convert it into joule. Okay, this is in kilojoule. So, you need to convert it into joules. Okay, this is in kilojoule, this is in joules. So, convert it into joules. So, it will be 77.2 multiplied by 10 raised to power 3 minus of 400 minus of 400, and what is delta S? That is given in joule only. So, it is 122, right? So, just solve this value here and then put it here. That is delta G is equals to minus 2.303 RT log of K. So, log of K will be equals to log of K will be equals to minus of delta G naught divided by 2.303. Okay, 2.303 R and T. Okay, again you know the value of R, that is 8.314. Put the value of T, you will get your answer, right? Okay, okay, yes, done. Beta, calculation, what I'll tell you with the calculations, just solve it and do the calculations. What I need to tell you about the calculations, right? Okay, calculation, what you need to know here, calculation is all practice, right? You need to practice it. There is no different trick that I'll tell you about the calculation. 4 multiplied by 2 is 8, that only I'll tell you, right? This is how to do multiplication, subtraction, right? So, what I have to tell you about calculation when you are talking about JEE mains, right? Okay, chalo. So, this is, you just solve this, but remember that take care of the units, okay? Some students, what they do, in hurry, 77.2, just put it directly, right? They will just put it directly. What will happen? They will get the wrong answer, right? So, take care of the units here. Kilojoule, it is joule, so it will be all in joules, right? So you will get the answer. Answer will be, wait a minute, that is 28400 joules. Why you will get it in joules? Because everything you have put it in joules, right? So this is in joules only. Now after that, put the value here and you will get the answer. See, they are not even asking you to take the anti-log here. So they're just asking the value of log k. So that will be minus of this. Okay. Okay, Ji. Now, bacha, one more thing. Also remember one thing. In integer questions, they will always give you something like this. Dash into 10 raised power minus 1. Some students, they will put it directly, that is minus 3.7. They are asking you to convert it into the value of into 10 raised power minus 1. So a decimal will shift here and you will have this as the answer. This is going to be the answer. Okay? Hanji? Yes? Okay, everybody? Chal. Now, next is, this is a simple question. What about this, Smita? Which of the following is not correct? Delta G is negative for spontaneous. This is Gibbs Helmont equation. No, this is simple. They are asking you. Is negative for spontaneous? That is true. Positive for spontaneous? It is not true. Delta G is 0 for reversible reaction. Is positive for non-spontaneous. So which of the following is not correct? Everybody, I have already answered it. Hai na? Which of the following is not correct? B is the incorrect option, incorrect statement. That means it is the correct option. Okay? Yes. Think by mistake I have put it here. Chalo. Next question is, an ideal gas undergoes cyclic transformation starting from the point. Now, this is a very, very simple question, guys. It's just that you will see that this is a different, but it's a very, very simple question, okay? It's a very, very simple question. Everybody, try to solve it. Very, very simple question this is. An ideal gas undergoes a cyclic transformation starting from the point and coming back to the same point by tracing A to B, B to C, C to D, C to A, as shown in the diagram. The total work done. Beta, work done is equals to minus P delta V, right? Okay. What is P? What is P? What is delta V? You need to tell me here, right? Okay. Pressure or this. Acha. They are asking the cyclic, na? Cyclic means they are asking you basically the area enclosed here, right? What is this area? This is the area that is enclosed. Beta, tell me what is the formula of a right angle triangle? What is the area of right angle triangle? Area of right angle triangle is what? Hanji, everybody, what is the area of right angle triangle? Very good. So area is equals to half of the difference here, that is 30 minus 10, that is going to be 30 minus 10, 20, and the difference here, that is 30 minus 10, again it is going to be 20, so it is going to be 200. Okay, it is going to be 200, right? Okay, yes, everybody. Chalo. Very good. So answer is going to be 200. Right? Okay, ji? Chalo. Next question is, two reactions are given below. This is what I was telling you. Thermochemistry cannot be understood with the help of theory. Thermochemistry can only be understood with the help of some questions here. Right? Okay? Yes. Acha, I forgot to mention clockwise or anti-clockwise. So this is clockwise, so it will be, yes, negative, right? Okay, yes, clockwise is negative now, so it will be negative, right? Okay, so you can put it here, right? Okay, ji, chalo. Now, next is two reactions are given below. Fe plus 3 by 2 O2. I think that is not clear to you, so I'll just write it here. 2 Fe plus 3 by 2 O2 give rise to Fe2O3, and this is delta H is given to you minus 8 to 2. I think Hess's law will be applied here. right? This is CO, this is O2, this is half, this is C. They are asking you C plus Fe, C plus Fe2O, right? Okay, give rise to this. If you multiply this by 3, this is the first equation, this is the second equation, and then you subtract 2 from 1, then according to Hess's law, you will get this particular enthalpy. Okay. Okay. Hanji. Wait a minute. What happened here? Let me just check. Clockwise was negative, right? It was given to be clockwise. Where it is clockwise? It is clockwise, na? So it will be negative. So you can put negative here, right? So it will be negative, right? Okay. Yes. Chalo, abhi let's go to the next question. That is this one. Two reactions are given below. Two reactions are given below to you, right? Okay. Wait a minute, yaar. This is negative. Wait a minute. Wait a minute. This will be clockwise. Chalo, we'll see that. We'll see that. I'll tell you that after some time. Chalo, firstly, so let us see this thing here. Right? This is basically when you multiply the second equation with 3. So this enthalpy will be multiplied by 3 minus of minus 8 to 2. Okay? Minus of minus 8 to 2. That you will do here. Okay? Now, the enthalpy of this reaction they are asking you, that will be equals to 3 multiplied by this minus 110 minus of minus 822, right? Because you have multiplied 2 with 3, then you get the answer, right? 2 is multiplied by 3 minus 1. Okay, just solve this value and you will get your answer. Got it? Okay, ji? Right? Okay. Acha. Okay, I'm so sorry. That's what I was thinking, that why it is so. Very good. Who has answered this? Let me see. Sachin. Very good, yaar, Sachin. But it was also in my mind. I was thinking, in my back of my mind, it was going on that why it is so. Achha, guys. So what I told you was for PV diagram, okay? For PV diagram, the clockwise was negative, right? So when you talk about VP, it will be opposite. So VP clockwise will be positive. That is why here answer will not be negative, okay? It will be positive only. So just erase it there. If I have written somewhere that it will be negative, it will be positive only, right? Because it is VP diagram, it is not PV diagram. Okay, just see this thing here, right? Okay. Okay, ji. Very good, Sachin. Very good. Shabash. Full attentive you are in the class. Very good. Chalo. Now, next is, acha, this to beta I told you that simply just solve this, right? Next is, consider the following reaction. Now they are giving you the following reaction. They are giving you the value of Kp. Basically, equilibrium constant is given to you, delta G for the reaction they are asking. So same way beta, same way things will happen, right? But they are asking in kilojoule, okay? Just remember, joule will be converted to kilojoule, okay? Very good. So here also same thing will happen. Same formula will be applied, everybody. Same formula will be applied, shabash, everybody. So that is delta G naught is equals to minus 2.303 RT log base 10 of Kp, right? Okay. So the value of delta G naught will be minus 2.303. R is what? 8.314, that is in joules, right? Okay, temperature is given to be 298. Log of Kp is nothing but 2.47. multiplied by 10 raised to power minus 29. 10 raised to power minus 29. Okay, so solve this value delta G naught. Solve this value of delta G naught. Right, okay, solve this value of delta G naught. Right, okay, and you will get the answer. Right, after that they are asking you convert it into kilojoules. Right, then just convert it into kilojoules. This will be the value that you will get. Then convert it into kilojoules, and that will be the answer that you will have. It has nothing to do with the reaction. Okay, so don't get confused there. Right, okay. Next question is 5 moles of an ideal gas. Next beta, they are asking you 5 moles of an ideal gas expands from 10 to a volume of 100. Okay, under isothermal, again the same thing is isothermal thing is given to you, but here they are giving that it is a reversible condition. Or they could have given you at variable external pressure. That would also be, we can ask you here, just write it here, variable external pressure. Sometimes they don't give directly reversible, sometimes they give variable external pressure. Variable external pressure, right? That could also be given to you. Now, if in this way, which formula will be applied? Just tell me the formula. If you know the formula, calculation is not a big deal, right? Just tell me the formula here. Just tell me the calculation. Yeah, calculation is right. For this though, you also need to know. That's why I always tell that if you don't know how to calculate the value of log, right? Log is very, very important, right? Okay, so you need to learn that how to calculate the value of log and anti-log, right? Because in physical chemistry, you can't work without log and anti-log, right? Okay. Now, bacha, which formula will be applied? Integration formula will be applied. Integration formula will be applied. Okay, which formula will be applied, guys? Integration formula will be applied here, right? And that too, which one? Which has volume, because what is given to you? Volume V1 and this is V2. So you'll apply the formula, that is W is equals to 2.303 nRT log V2 by V1. For pressure, it is P1 by P2. Just put these values here. The calculation is not that tough because log is simple. In the previous question, the log was tricky. Okay, so here just put this very simple, right? So it is going to be the answer. Okay, just solve this, do the calculation, and you will get your answer. And answer will come out to be this, right? Okay, that is going to be the answer here, right? Okay, Ji. Now, one more thing here. Here they have written the work will come out to be minus x. Minus x. Then what is the value of x? And students will write that the value is minus 28721. But they have given minus x. That means x value only you have to take. It's like you know everything, you have answered everything, still you are answering the wrong thing, right? Okay. So be aware of these little things, especially in integer based questions. Okay. Next is the enthalpy formation. The enthalpy of formation of ethane from ethylene by addition of hydrogen, where the bond energies are this. Okay. So ethylene means you have this thing, I'll just draw everything here, all the bonds. This is what I'll telling you. Thermochemistry is very simple, but for thermochemistry, you need to understand two things, that whenever bond energies is given to you, reactant minus product it will be, right? Not product minus reactant. So the reaction will be CCH. So that means the enthalpy is going to be what is given to you, CH, CC, C double bond, and HH is given to you. So the enthalpy change is going to be, enthalpy of formation, they are saying now formation means 1 mole is produced here. So enthalpy of formation is going to be, reactant is what? Reactant is 4CH, you have 4 into CH bond energy. Reactant minus product, whenever you have hint is given for bond energies, it is reactant minus product. Okay, don't do the opposite. 4 into CH plus you have C double bond C plus you have H or H, you have one H bond, right? minus, you have minus of, you have one CC bond, and minus of 4 into CH bond. No, 4 nahi, 6 into CH bond. 1, 2, 3, 4, 5, 6. Right. So this 4 and 6 CH bond will be eliminated. So answer will be here. It is having one C double bond C plus one HH bond, right? Minus of CC bond and minus of 2 CH bond. Okay. So this thing is given to you. CC bond is given to you. CC bond is this. This is CH. This is CC. This is double bond C. This is HH. So just put the values here and you will get the answer in kilojoules. Okay? Understood? Yes, students, understood what we are doing here? Right? Okay, Ji. Okay, everybody. Is that clear or not? Is that clear or not? Is that clear? Okay, why we have done reactant minus products, not products minus reactant. If they would have given combustion, formation, anything else, then we would have done product minus reactant, that we did in the previous question also. Right? Okay, so this is what you will do here. This is the thing that I have written. Okay, understood, guys? Everybody? Okay, understood? If that is clear, let's jump to the next question. That is 3 moles. Now they are saying 3 moles of an ideal gas. You have 3 moles of an ideal gas. Yes, everybody, you have 3 moles of an ideal gas. Very good. Yes, ma'am. Yes, ma'am. Okay. 3 moles of an ideal gas are compressed isothermally from this to this using constant pressure of this. So everybody, tell me, is this, dekho beta, that is only I told you na. Those 2-3 questions, type of questions are only repeated. At constant pressure, this is a P external, right? This is P external, 5 atmospheric. This is a irreversible process, right? At constant pressure means it is a irreversible process. So we'll use work done is equals to minus P external delta V, right? You will just put the value here and you will get your answer. This is minus 5, 60 minus 20, and solve this and you will get your answer. Is that clear? Is that clear? This is given in liter, that is given in atmospheric. So it's very, very simple question. Okay, not even any calculation, nothing is required. So it's a very, very simple question. Okay, Ji? Right? Achha, let me see. They are asking the heat exchange now. So we'll calculate the value. I think this is repeated. Is it? This is a repeated question. Work done you will see from here. We know that delta U is equals to Q plus W. If this is 0 for isothermal, Q is equals to minus W. W is coming out to be, let's say W is coming out to be 200, right? Let's say W is coming out to be, W will be minus, na? It will be minus of this. Okay? Wait a minute. 60 to 20 it is. Achha, it is 60 to 20. This is V1 and this is V2. So V2 is this. So V2 is 20 minus 60. That is why it will be positive of 200, right, joules. Now Q is equals to minus of this. So it will be minus of this. So answer will be minus of 200 is going to be the answer, right? Chalo. Now next students, next is your statement based question. Everybody try to answer this. Everybody in the comment section, try to answer this question. Everyone, try to answer this question, guys. Given below are 2 statements. One is labeled as assertion, other is labeled as reason. Enthalpy of neutralization of a strong monobasic acid with a strong monoacidic base is always minus 57. This is basically from practical chemistry also we do this, right? So enthalpy of neutralization for a strong monobasic and like NaOH, HCl, it is minus 57 kilojoule per mole. That is true, right? Okay. Enthalpy of neutralization is the amount of, what is enthalpy of neutralization? This is from thermochemistry basically. In thermochemistry, you have different definitions. So from that only, other definitions are not that important. Only this definition is important, right? Enthalpy of neutralization is the amount of heat liberated when 1 mole of iron furnished by acid combined with 1 mole of OH furnished by the base. OH given by base and H given by base, that is the true. Okay, this is the enthalpy of neutralization. When strong acid and strong base, H positive and OH negative, they combine and neutralize each other. So, both are true. That is the true thing. Both are true. But we have to see whether it is the explanation. So, first let us put why. Why enthalpy of neutralization of strong monobasic and strong monoacidic acid is always this? Because it is 1 mole of OH negative when it combines with 1 mole of H positive. 1 mole of H positive. So, when you do the calculations to calculate this enthalpy, now we take 1 mole. That is why for monobasic and monoacidic, answer is coming out to be this one. So, it is the correct explanation also. So, answer is going to be C. Okay? Right? Okay, Ji, answer is going to be C is the correct answer. Okay, next question is, guys, the heat of combustion. Everyone, the heat of combustion, everybody. The heat of combustion of solid benzoic acid at constant volume. Heat of combustion of solid benzoic acid at constant volume is minus 321.30 at 27 degrees Celsius. The heat of combustion at constant pressure is this much, the value of X they are asking you. Enthalpy of combustion of solid benzoic acid at constant volume is this. Okay. Heat of combustion at constant pressure they are asking you. Yes, everybody. At constant pressure, what will be the heat of combustion? Yes, everybody. So, heat of combustion of solid, heat of combustion at constant pressure. Beta, heat of combustion at constant volume is QV. That is given to be minus 321.3 kilojoule, right? They are asking you the value of heat of combustion. It's a very interesting question. It's a good question, okay? So, heat of combustion at constant pressure, that is minus 321.3 minus X into R, this kilojoule. Easy, good conceptual question, okay? So, what is this QV? That is nothing but it is delta U. It is nothing but we are talking about delta H only, right? Nothing but we are talking about delta H only, right? So, can I just write it delta H here? Right? Can I just write delta H over here, guys? Everybody. Let me know. Can I just write delta H over here? Delta H is equals to QP, right? Now, do we know there is one formula that is delta H is equals to delta U plus delta PV, but PV we don't have. We have R. This answer is in the form of R. So that means I will put the value of delta Ng, and also I have one chemical reaction they are giving me. Solid benzoic acid to this. So it is delta NgRT. Right? Okay. Temperature is given to be 300. Temperature is given to me 300. Right? Now, what is the value of R and delta Ng? Now, Bacha, tell me what is the value of R and delta Ng? Shabash, everybody. What is the value of R and delta Ng? Delta Ng, for that you need to know the formula, the reaction here. Benzoic acid, heat of combustion, that means you add oxygen in benzoic acid, right? Add oxygen in benzoic acid. Add oxygen in benzoic acid. So, if you talk about benzoic acid, that is C6H5COOH, you add oxygen here. You will get, so whenever you add oxygen in acid, you will get carbon dioxide and you will get water here. For this now, you also need to balance this reaction, okay? Can you do the balancing, everybody? can you do the balancing here, or I'll just directly tell you the balancing. Balancing, so you know na, firstly balance oxygen, then hydrogen, then balance the other atoms. Okay. So firstly, you will balance, firstly you balance carbon, then oxygen, then you balance hydrogens. Okay? Yes. Okay, Ji. Understood, guys? Everybody? Who will do the balancing? Balancing, I'm waiting for your balancing, yeah. Or I'll just directly see. Okay, balancing, to firstly balance carbon here. 6, 7 carbon you have. Here you have to put 7. Right? Here you have to put 7. Right? Here you have to put 7. Carbon we have balanced. Let's balance oxygens now. Oxygen, how many you have here? This is 2, 4 oxygens you have. You will not do anything here with the balancing. Just you can change the moles here, here and here. Why? Because otherwise you will change the carbon also. Then again you will stuck in that loop. Right? So this is 7. You can calculate the oxygens, or I would say firstly calculate the hydrogens. Okay, if you see the hydrogen, because oxygen is here and here also. So we can balance the hydrogens firstly. So hydrogens, how many you have? You have 2 hydrogens here. And here also you have 2 hydrogens. So hydrogen is balanced. So I need to balance the oxygen now. Main task is to balance the oxygen. So here oxygen is 7 to 14 plus 1 is 15. Here it is 2, this is 2. Right? Okay. So if I want to have 15 oxygens here, what I need to do? What I need to do, everybody? 3 water, 3 water, 3 water. Let me see. If you put 3 water here, let's try this. If you have 3 here, so because we need to make it even, so it will be 7 to 14, and this is 3, 14, 15, 17. 17 you can make here. How you will make 17 here? Right? How you will make 17 there then? Huh? Acha. Take it. So you can do, this is 15 by 2. So that will be something around plus 2 plus 17. Okay. Because this will be cancelled out. 15 plus 2, this is 17. Take it. Okay. Hydrogen is balanced now. Hydrogen is 5, 6 and this is 3, 2. Acha, I didn't see hydrogen balancing. That's why. Achha, hydrogen is 6 na, chalo theek hai. This is the balancing na, so balancing you can do. After balancing, just calculate delta Ng, right? Delta Ng is, you need to see the gaseous products here. This is gas, this is solid, this is gas and this is liquid. Okay, so what will be the delta Ng value, everybody? What will be the value of delta Ng? Only see the gaseous products, okay? Don't see the don't see the liquid and solids. What will the value of delta Ng? 15 plus 3, 18. 15 plus 3, 18. Where it is 18? 3 need 2. 15 to 15, 16, 17. Okay, here it is 7 to 14, 15, 16, 17. 17 only beta we are getting. So it will be 15. Product is how many gaseous moles you have? 7 minus 15 by 2. Right? It will be minus 1 by 2. So it will be minus 1 by 2. So it will be delta U. Delta H is equals to delta U plus, we know that it will be minus 1 by 2 R, and what is T? T is 300. So it is going to be delta U minus 150 R. Okay. So that is going to be the value. Delta H is equals to, delta is given you minus 321. 0.30 minus 150 R. They are asking the value of X here. So X is going to be 150. Okay. So answer will be 150 is the correct answer. Okay. 150 is the correct answer. Okay, Ji. Chalo. Next question we have. That was a good question, right? Okay, Ji. Chalo. Next is Consider the figure provided 1 mole. It is also very simple question, right? SI figure you will see it is tough, but otherwise it's a simple question only. Consider the figure provided 1 mole of ideal gas is kept in a cylinder. This is the cylinder fitted with the piston at the position A. This is the position A at 18 degree. If the piston is moved to position B, keeping the temperature is unchanged, that means it is an isothermal process. First thing is it is isothermal. First thing is it is isothermal. Write it here. Right? Keeping the temperature unchanged, then X liter atmospheric work is done. Okay. Work they are asking you in this reversible process. They are giving that this is a reversible process. That means integration you need to do here. Right? Integration you will do here. Okay? Integration you will use here. Right? Okay. Now, integration we will do here. Right? Integration formula we will use here. Right? From there you need to calculate the value of work. Right? That will be X liter atmospheric. Now, what is the value of X? They will ask you. For that, guys, volume is given to you. V1 we know that is 10 liters. V2 is 90 plus 10, that is 100 liters. Right? This is V1 and this whole is volume has increased, so it is V2. Right? Okay, V2 is given to you. Right? So we will use V1, V2 formula. Right? And temperature is also given to you. Temperature is also given to you. Just use the formula and get your answer. Right? Okay. Use the formula, convert it into Kelvin. Convert it into Kelvin by adding 18 plus 273. Right? Convert it into Kelvin. Right? And use, they have also told you to use the value of R is this. This is what you need to use, R. Right? Okay. Yes, everybody. Yes, everybody. Log 10. Haan, very good. Very good, very good. Reversible log V2 by V1. Shabash. Can I see the answers in the comment section? It will be 2 log. Very good. Yes, it will be 2 log. Shabash. Very good. You are doing it right. You're doing it right. This was the main part. Everything else is very simple. Okay? Yes. Hanji, everybody. Is that clear? Chalo. Now, very simple thing. Write the same thing. Right? So, just use this formula of integration that we got from integration V2 by V1. N. Acha. Ma'am, how can you say 1 mole? It is given to us here. Right? So, 1 mole. R is already given to us in the question. Temperature converted into Kelvin. Log, for that you need to convert into, you just use log. Right? This should be multiplied by 2.303. Okay? Then it will cancel out. Right? It will cancel out. Log will be 1. Log 10 is nothing but 1. Just solve this value. It will be minus of 2.082. Right? Multiplied by 291.15. Multiplied by 2.303. And this is the answer that you will get. Right? Okay? Now, what is X? X is X liter atmospheric. Right? This is what they are keeping the temperature unchanged. Then X liter atmospheric work is done in this irreversible process. Right? So, the work done will be this approximately 55 atmospheric liter work is done in this. Now, you will say, ma'am, they have not written positive or negative here. Right? Because beta, they have written work is done. That means work is done by the system. Right? The work definitely will be negative only. So that's why if they would have written work is equals to this, then they would write negative of this. But now they have given it in the statement, work is done in this. That means work is done by the system. Okay? Right? Okay? That was a nice one, Manish. Physical chemistry in integer. Right? That's why integer questions are mostly, you will see it is from physical chemistry only. Right? So guys, that's it for today. Right? So did you like today's session? Everybody in the comment section, let me know, because we have done thermodynamics complete also. Then we also saw that what kind of question they can ask you. As you can see, Mostly in thermodynamics, integer kind of question they can ask, right? Calculation plays a very important role here. Knowing the language of the question is even important, right? Because calculation is about practice, but even if you're very good in calculations but you don't know the concept behind it, where which formula will be applied, right? So basically in thermodynamics, what you will see, you will find it tough to see which formula will be applied. So that's why I have done complete detailed revision before. After, if I would have just picked it without doing revision, you will get very, very confused in that, right? So that's why we have done revision firstly. Now, even if they ask you something from heat capacity, which is a very important topic, they can ask you other things also. So everything we have done in detail, right? Okay, if you watch the revision session and you do the practice question, not only these, I would advise you to do the last at least 3 to 4 years questions, previous year questions from this chapter. You don't need to do any other thing, just do the previous year questions. Okay, just do the previous year question. That is my advice to you, right? Okay. Okay, chalo. Okay then, beta. Bye bye. Take care and good night. It's 11:30 already, and now you guys also should sleep, because tomorrow we are going to solve mock test, right? You can see the link, right? That is in the live section, right? So tomorrow is going to be our first mock test. So everybody, I'll be waiting for you to come live and join it, and we will solve, right? Physics, chemistry, and mathematics, all three subjects we will do tomorrow. Okay, then, bye bye. Take care. See you all. Good night, and take care of yourself. Have sweet dreams. Bye bye. And also, I do see your comments. So I'm waiting for your comments in the comment section. Okay, I do see your comments, and it makes my day, right? It keeps me motivated to make these notes for you. So I'm waiting for it. Bye bye.